Section 5.2, using intercepts. So let's get right into this section here. So miners are exploring 90 feet underground. The miners ascend in an elevator at a constant rate over a period of 3 minutes until they reach the surface. In the coordinate grid, the horizontal axis represents the time in minutes from when the miners start ascending, and the vertical axis represents the miner's elevation. So notice it's kind of upside down because essentially the reason it's upside down is because the elevation here is our negative numbers. So 90 feet below the ground is way below the ground. So they're going to be ascending over a certain period of time, right? Something kind of like that. So what point represents the miner's elevation at the beginning of the ascent? So remember, the miners are exploring 90 feet underground. So at the beginning, or where they're exploring, they're 90 feet below the ground. So beginning of plot this point. All right, so it was at negative 90, essentially. What point represents the miner's elevation at the end of the ascent? So they're rising from that level over a period of 3 minutes. It takes them 3 minutes until they reach the surface. So at 3 minutes, they'll be at the surface, right? So there are your intercepts, right? The Y-intercept is at the very beginning, time 0. The miners are 90 feet below the ground. But the X-intercept is at 3, meaning it's 3 minutes when the miners have reached the surface. And so now we connect those points to kind of make a graphical representation of where the miners were over those period of 3 minutes, right? What their ascent looked like. This was really, I guess we should really make it more like ordered pairs. So 0, negative 90, and in this case would be 3, 0. All right, so we connect points with the line segment, right? What is the point where the graph crosses the y-axis and the x-axis? So the y-axis, the point, of course, was that y-intercept, which was 0, negative 90. And the x-axis, which was 3, 0. So the point where the graph intersects the y-axis represents the beginning of the miner's ascent. Will the point where the graph intersects the y-axis always be the lowest point on a linear graph? Explain. No. So for example, the reason it might not be, here we go, it's lagging again. Okay, I'll just explain this rather than writing it out because my pen's a little on the iffy side right now. The reason it might not be is what if, so give an example like where you have people from the top of a building who are going down an elevator to the ground level, right? Then at the start, they're at the very top of the building, right? So their y-axis, their y-intercept would be really high. And then over time, their climb would be descending until they landed on the ground, right? So the y-intercept in that case would be the highest point, not the lowest. And it could definitely vary from time to time, depending on the situation you're given. So the graph in the Explore intersected the axis at 0, negative 90, and 3, 0. We just talked about that in the last one. The y-intercept of the graph is the y-coordinate of the point where the graph intersects the y-axis. The x-coordinate is the point is always 0. The y-intercept of the graph in the Explorer was at negative 90. The x-intercept, of course, the x-intercept, just kind of summarize it. The x-intercept where it hits the x-axis, and no matter where it hits the x-axis, the y-coordinate will always be 0. And of course, on that previous example, it was the x-intercept was at 3. Now, find the x and y-intercepts. So this information that we just read, some of it was rather important. Let me highlight some of the parts that were important. So for the y-intercept, the x-coordinate is always 0. For the x-intercept, the y-coordinate is always 0. Okay. Now that's crucial because if you look at example A, what they're going to do is make things simple. They're going to graph this line not by using slope-intercept form or finding coordinate or finding ordered pairs of the line that we did in like 5.1. They're just going to find the two intercepts and connect the line through those. So because they know this fact, if they want to find, for example, if they want to find the x-intercept, then they already know that the y value will be 0 at that particular spot. So what they're doing is they're taking the equation, they're putting 0 in where y was, right? And they're solving for x. That gives you the x-intercept, essentially the point 2, 0. Again, my pen's still a little bit wonky, all right? Sometimes it works well, sometimes it doesn't. The x-intercept being at 2, 0, because x is 2, y is 0, fits our equation. So they would plot that, and then they would do, okay, so that's the x-intercept. Now they would find the y-intercept, and they know that no matter what the y-intercept is, the x will always be 0. So they're taking the equation, and they're plugging 0 in for x. That cancels that whole term out, of course, and they solve for y. Solving for y gets the y-intercept to be -3. So now you know 2 points on your graph. 2, 0, and 0, -3. Again, apologize. My pen's not working very well. All right, and they can use that information, plot it on a graph, and connect the dots to make their line. So now let's look at an example of our own. Hopefully my pen will decide to start working. All right, -5x plus 6y equals 60. So if we want to find the x-intercept, we're going to replace y with 0. Okay, it seems to be working pretty well now, right? So we want to find the x-intercept, then we're going to plug 0 in for y. So we have the equation -5x plus 6y equals 60. Well, we're taking the y out. We're putting 0 in its place. Now, 6 times 0 is 0. Essentially, that whole term just disappears. So we're just left with -5x equal to 60 that you see here. And we solve. We simply divide by -5, and we get x is equal to -12. So we have the x-intercept is -12, 0 as the order pair. And if we want to find the x-intercept, we replace the x with 0. So solve for the y-intercept. I don't know if I said that backwards. Solve for the y-intercept, replace x with 0, and then solve for y. So remember, you have your equation, -5x plus 6y equals 60. Essentially, we're going to take this x, put 0 in its place. And -5 times 0 is nothing, so it disappears, and we're just left with the equation 6y equals 60. So when we divide by 6, we get y is equal to 10. So we know that the y-intercept is at 10. And don't forget, in your ordered pair, for your y-intercept, remember, x was always 0. We talked about that earlier. X is 0. That's what we plugged in the equation. So the x value in this is 0. And when we solved for the y value, we got 10. And back on the first part, remember, we said y was 0. So that's why you see in our ordered pair, the y was 0. And then we solved for x. X was the -12. So make sure when you write your ordered pair, you remember which number is which, and which part of it's 0. If you're talking about the x-intercept, the y value should be 0. If you're talking about the y-intercept, the x value should be 0. All right. If the point 5, 0 is on a graph, is 5, 0 the y-intercept of the graph? Explain. This is no. This is not. The reason why is because 5, 0 would be the x-intercept. 5, 0 is on the x-axis. 5, 0 is on x-axis, not y's. And you can tell, not only because if you kind of imagine it on a graph, but you can tell because the x value is 5 and the y value is 0. And we know that anytime the y value is 0, we are looking at the x-intercept. Okay? X-intercept is when y is 0. The y-intercept is when it would be the other way around, with x being 0. Okay, so for these examples, let's try a few on our own, right? Let me zoom in a little bit so we can see it better. Okay, so if we want to find the x-intercept, right, that means we're going to plug in y as 0. So we're going to have our equation, 8x plus 7 times 0 equal to 28. Now 7 times 0 is 0, so that kind of cancels out, disappears, and we're just left in the equation 8x, I thought I went back to purple there, 8x is equal to 28. So divide by 8, and we end up with x equals 3.5. So we know the x-intercept is 3.50. When we want to find the y-intercept, right, that means plugging in 0 for the x value. So this would be the equation 8 times 0 plus 7y equal to 28. And then, of course, 8 times 0 is 0. So that's going to cancel out. And now we have just 7y equal to 28. So when we solve for this, we get y is equal to 4. So we know that the y-intercept is at 4. And there's your 2 points. All right, let's practice one more, number 4. So the x-intercept, remember the x-intercept is when what value is 0? The y value. So we're going to plug this in, negative 6x minus 8 times 0 equal to 24. So 8 times 0, as we already know, is 0. It cancels out or just disappears. So we have just negative 6x is equal to 24 to solve for. Divide by negative 6, then we end up with x equal to negative 4. So we have the x-intercept of negative 4, 0. And now when we want to solve for the y-intercept, we're plugging in x as 0. So that equation would be negative 6 times 0 plus 8y, or I'm sorry, minus 8y equals 24. Let me just make sure I wrote that down right. Yeah, okay, that's the correct equation. So negative 6 times 0 is, of course, 0 again, so you're just solving for the negative 8y equal to 24. And when you do that, we end up with y equals negative 3. So the y-intercept would be 0, negative 3. All right. Rather straightforward, more or less. Depends, you know. It's pretty much the same thing every time. You're just plugging in 0 and then solving essentially half the equation. So you're making a one-step equation pretty much every time, and it goes by pretty quickly, and you shouldn't really have too much problems with it. Okay, now interpreting intercepts of linear equations. So what do the intercepts mean? Back in our first example, remember the y-intercept meant where the miners were at the beginning of the process, and the x-intercept was where, or the time when the miners reached the surface. So we have to make sure we understand the context of some certain problems. All right, so in example A, Sandia Park Tramway in Albuquerque, New Mexico travels a distance of about 4,500 meters to the top of Sandia Peak. Its speed is 300 meters per minute. The function 4,500 minus 300x gives the tram's distance in meters from the top of the peak after x minutes. So they plotted their intercepts. So they already kind of knew that at the beginning it's 4,500 meters above the surface, so they already have that y-intercept plotted. They went ahead and plugged in 0 for the y part of the equation, which is the f of x being the same as y. So they put 0 over there, and they solved for x, and they got x was 15. So that's how they know the x-intercept is 15. But now we have to interpret it, right? To understand what that means, it means that it takes 15 minutes for that tram to reach the peak, as it says. It takes 15 minutes for the tram to reach the peak. Essentially, at the beginning, they're 4,500 feet from it, right? And as the tram gets closer and closer to the peak, when they're 0 feet away from the peak, remember the y-axis, the y value being 0, this is when the distance is 0. Up here is when the distance is 4,500 feet away, but this down here at the bottom is when the distance is 0. And that's at time 15, meaning at 15 minutes, the distance from it is 0, meaning that they are there. They have arrived after 15 minutes. So a hot air balloon is 750 meters above the ground and begins to descend at a constant rate of 25 meters per minute. The function represents the height of the hot air balloon after x minutes. To find the x-intercept, replace f of x with 0 and solve for x. So again, we already know the y-intercept from this problem at 750. We see that there. But in order to graph this, you have to solve for x. You have to plug the 0 in for the y. You have to do some math. So what we would do, trying to solve this, let's write it out over here on the side, right? Just to show you the steps, because they do kind of a little bit too much. What was it? 750 minus 25x? 750 minus 25x. Here's what we can do, right? If we're trying to solve for x here, let's move the 750 over to the other side. So we'll subtract 750 here, and then of course do it to the other side too, right? So that cancels it out. We have negative 750 on the left is equal to negative 25x on the right. And now we can just divide by a negative 25 to cancel this out. And of course, do this to both sides. So we end up with x equal to the negative 750 divided by negative 25, which comes out to be a positive 30. So that's how we get the x-intercept at 30. Okay, x is equal to 30. So ultimately what this means, it takes 30 minutes for this hot air balloon to reach ground level, right? This is the ground. This is 0 feet above the ground, which means it's on the ground, whereas at the beginning they were 750 feet above the ground. But this point shows the time at which the hot air balloon was 0 feet above the ground, essentially when the hot air balloon is on the ground, and that time was 30 minutes. And you can just double check, you plug in 30 here, you find out that, to find the y-intercept, of course, we already knew this. To find the y-intercept, you plug 0 in for x, you end up with 750. But again, we kind of already knew that at the start of the problem because it sort of just, it said, hey, you're starting at 750 meters above the ground. Okay. Number 5, a classmate says the graph shows the path of the tram. Do you agree? So back to example A. This is not the path of the tram. Okay, it's not kind of a visual representation of the tram. It's essentially just claiming its distance. So it's kind of like if I said I got up here and I walked towards the door, right? This is not showing my path towards the door. It's only showing, over time, how far away I am from the door, how many feet from the door I might be. So it's not a representation of its path. It's just a representation of its distance compared to time. It doesn't necessarily show its direct path. The temperature in an experiment is increased at a constant rate over a period of time until the temperature reaches 0 degrees Celsius. The equation there gives the temperature in y degrees Celsius x hours over after the experiment begins. Find the x and y-intercepts. So if we want to find the y-intercept, this would be the easiest. The y-intercept is when x is 0, so we have y equals 5/2 x minus 70. But if we're finding the y-intercept, then we're going to plug 0 in for x, which is convenient because you'll notice that gets rid of the fraction, and we simply have the solution that y is equal to negative 70. So we know the y-intercept is at negative 70. Now, if we want to find the x-intercept, it's a little hard. We got to plug 0 in for the y. So we had y equals 5/2 x minus 70, but we're going to plug 0 in for the y. So we have 5/2 x minus 70. So what I would do first is I would add 70 to both sides, making this equation 70 equals to 5 over 2x, or 5/2 x. Now what I would do here is I would treat this fraction in separate parts. I would see the denominator of 2, and I would get rid of it by multiplying by 2. So I would multiply this side by 2 just to cancel out that 2. But if I multiply it over there by 2, I got to do it on the other side as well. So this would come out to be 140 equal to 5x. So again, notice what I did. I decided to get rid of the denominator, and to do that, I would have to multiply. So I multiplied by 2 to cancel it out. And of course, since I did it on the right, I had to do it on the left as well, making 2 times 70 equal to 140. Now just divide by 5, and we get our answer. X is equal to, I think that's 28. So our x-intercept is at 28. All right, I'm going to end the video here. If we have more to do, we'll do it in another video. I just don't want to take too terribly long, but we got most of it done. So see you guys in class later.